Hi everyone, it's Mrs. Meehan, and this is the first lesson of our first unit, which is kinematics. Kinematics is the science of describing the motion of objects in various ways, so we can use words, diagrams, numbers, graphs, and even equations. That's what we'll be working with in the beginning of the course. The motion that we'll be examining will just be in one dimension. So forwards versus backwards, or up versus down. That is what we'll be covering at the college prep level. We won't be worrying about motion in 2 dimensions. So what I want you guys to do now, there are 2 clips you'll be prompted to view. The first clip, you probably recognize these guys, even if you're not a track buff like me, but we have Usain Bolt. He is the world record holder for the men's 100-meter race, and he is from Jamaica. And we also have Justin Gatlin, probably one of the fastest men in the US, but he's had some issues with testing positive for certain substances. So in these video clips, you're first going to watch Usain Bolt's record-setting performance. You're going to want to pay attention to what his time was, see if you can figure out what his speed was overall. Same thing with Justin Gatlin's clip, in which he actually breaks Usain Bolt's record in a very unique way. So you'll see what that is in a moment. The second thing to consider in the question that will come up is, what would you call this type of speed? Would this be an instantaneous speed? Notice the word instant is in there. Or if not, what would you call it? What type of speed is it? So take a moment, you will watch the 2 clips and then answer the questions that will be prompted on the screen. Okay, I hope you found that interesting. So if you did figure out their speeds, if you did get the answer correct, then you may have used an equation from the past. But what exactly is speed? You probably used speed equals distance over time, might be something that you remember from 8th grade or maybe prior math courses. But what that is telling you in words is that speed is a distance traveled over the course of a certain amount of time. So you would divide it by the time it took to travel that distance. So you end up with the equation speed equals distance over time. And abbreviating the words with letters, it's S equals D over T. For our units for distance, the standard is the meter. So we'll be using that in our measurements. For time, the standard for measuring time will be the second. Putting it together to figure out what the units are for speed, you just substitute the units for distance and time into the equation. So if distance is measured in meters and time is measured in seconds, then you get the meter per second as the unit for speed. That's what you should be using in your solutions. So here's a practice problem. Once upon a time, true story, Mrs. Meehan ran, or more like sprinted, 1 lap around a 400-meter track in 60 seconds. Can you calculate my speed in this example? And would this be considered an average or an instantaneous speed? So thinking back to the beginning of the lesson. Okay, so if you get the answer right, you would have used the speed equation to take the distance, which is 400 meters, divided by the time, 60 seconds, to get 6.7 meters per second, and that would be an average speed. An instantaneous speed would be more if, like a police officer with a radar gun measuring the speed of a car, it measures speed at a very specific instant, at that moment that he records the speed of the car. As opposed to this, I wasn't running 6.7 meters per second from start to stop. It most likely fluctuated as I went around the track. For the next question, a car travels at a constant speed of 10 meters per second. This means the car did which of the following? Make your calculation, enter it into the prompt. Okay, if you got it right, you should have gotten D as your answer. If you were describing this in words, speed in words, what it means, if you're going 10 meters per second, you have traveled 10 meters every 1 second. For the next question, a rabbit runs a distance of 60 meters in 20 seconds. What is the speed of the rabbit? If you got this answer correct, you would have used speed equals distance over time. We are solving for speed. That is the unknown in this problem. So we can plug in what we do know, which is distance, 60 meters, divided by time, which is 20 seconds, and you end up with 3 meters per second. For the next question, an airplane on a runway can cover 500 meters in 10 seconds. What is the airplane's average speed? If you got it right, distance divided by time would be that 500 meters divided by 10 seconds, which equals 50 meters per second for your speed. For the next question, a car travels at a speed of 40 meters per second for 4 seconds. What is the distance traveled by the car? Okay, in this problem, we are solving for distance. So you want to be careful. The equation is speed equals distance over time, but you want to rearrange the equation before plugging anything in. That is the rule of thumb in this course and any math course. So we need to isolate distance. To do so, you want to cancel out time, so you'll multiply on this side by time and multiply by time on this side. This cancels out. So you'll end up with distance equals speed times time. Plug in the numbers, you get 40 meters per second times 4 seconds, which equals 160 meters. You travel at a speed of 20 meters per second for 6 seconds. What distance have you moved? Again, you had to solve for distance, so rearrange the speed equation to get distance equals speed times time. 20 meters per second times 6 seconds equals 120 meters. You travel at a constant speed of 20 meters per second. How much time does it take you to travel a distance of 120 meters? In this problem, we are solving for time. So we need to rearrange the speed equation so that we get time equals distance over speed. To do so, you want to move time to the side of the equation. So multiply by time on both sides. And you want to move speed to this side of the equation. So divide by speed on both sides. You end up with time equals distance divided by speed, which is 120 meters divided by 20 meters. There should be a division symbol there. Equals 6 seconds. You you travel at a constant speed of 30 meters per second, how much time does it take you to travel a distance of 150 meters? Again, rearranging to solve for time. Plug in the given numbers. 150 meters divided by 30 meters per second gives you 5 seconds as the answer.